Now we're going to look at combinations. A combination is the number of ways to choose R objects from a group of N objects without regard to order, so order doesn't matter. In combination problems, the sequence ABC, CBA, and BAC is counted as one combination. We'll see how this formula is used in the following slides. So here's a combination problem. The marketing department has been given the assignment of designing color codes for 42 different lines of CDs sold by Goody Records. 3 colors are to be used on each CD, but a combination of 3 colors used for one CD can't be rearranged and used to identify a different CD. So this means if green, yellow, and violet are used to identify one line, then green, yellow, and violet, or any other combination of these 3 colors, can't be used to identify another line. Would 7 colors taken 3 at a time be adequate to color code the 42 lines? So the question is, would 7 colors taken 3 at a time be adequate to color code the 42 lines? So N is the total number, 7 colors to choose from. We would be selecting 3, so that's our R value. And it says the order of color selection is not important. So we are going to use this combination formula. Let's go over to another screen and we can take a look at this here. Okay, so we've got our combination equation, which is just slightly different from the permutation. It has the one addition to it. Okay, here we are. So all we're going to do is we are going to replace our N value and our R value. I'm just going to do this for us here. So N is our total, 7, and R is 3, the number we've selected. So now we can just go through and replace it. So we have 7 factorial on the top. We have 3 factorial times the quantity, 7 minus 3 factorial. So on the top here, it's 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial, 3 times 2 times 1. And I'm going to just put that in parentheses for us so we know that that goes there. Times 7 minus 3 is 4 factorial. 4 times 3 times 2 times 1. So let's get our calculator here. And we can do 7 times 6 times 5 times 4 times 3 times 2 times 1 is 5,040. 3 times 2 times 1 is 6. 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. And let's find out what 5,040 divided by 144 is 35. So if we go back to the other slide, it says, would 7 colors taken 3 at a time be adequate to color code 42 lines? Well, if we look at this, 35 is our answer. There's only 35 combinations, then no, it's not enough. So let's see what would happen if we added 1 color and changed that from 7 to 8. Let's see if that would make a difference. So if we go through here, and if we had 8 total, and we were still choosing 3, we had 8 factorial on the top, 8 minus 3 factorial. Okay, so I'm going to pull up the calculator. 8 times 7 times 6 times 5 times 4 times 3 times 2 is 4,320, 40,320. And we already know 3 factorial, 3 times 2 times 1 is 6. 5 factorial is 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. 6 times 120 is 720. Now I'm ready for the calculator again. 40,320 divided by 720 is 56. So now we know that we'd actually need 8 colors to choose from. We'd be able to have 56 combinations, which would be enough for us to solve this problem.